We're going to look at something called cross sections today. So we're going to look at two foods that are generally very close to the shape of a perfect three-dimensional object. The first thing we're going to look at is this banana. So I've cut this banana so that it is approximately cylindrical. So it looks like a cylinder. See, it's not perfect, but it's very, very close to a perfect cylinder. So the base is a circle on both sides of approximately the same size, and then we are connecting those two bases. So a cross section is what happens when I cut through a three-dimensional object. So if I cut approximately parallel to the base, if I cut off a portion of this banana, then this two-dimensional figure of where I made the cut, that is considered the cross section. So if I cut through a cylinder parallel to the base, that creates a circle. I can see here I have a circle where I made that cut. What happens if I don't cut parallel though? What if I cut diagonally through it? So I'm going to move this over. So instead of cutting parallel, I'm going to cut at a diagonal. Okay, so when I do that, I have kind of an oval shape. So it looks close to a circle, but it is not perfectly circular. I can tell because from the center, what would be the radius of a circle is not the same here as it is here. So it's kind of like a squished circle, which we'll call an oval. So that's another possible cross section, and that was when I cut diagonally through the banana. I could also get, let's cut this off so I'm back to an actual cylinder. So I'm back to a cylinder. This time I'm going to make a cut that is perpendicular to the bases. So not parallel, not diagonal, but perpendicular. So basically going right up and down through this cylinder. Okay, when I do that, looking straight on top of the banana, I can see that that looks like a rectangle. So this two-dimensional surface here is a rectangle. I have 90-degree angles. I have opposite sides that are congruent to each other. So if I cut kind of up and down through the cylinder perpendicular to the base, then I would get a rectangular cross section. These are both rectangles. Okay, let's look at a rectangular prism. So I have part of a slab of butter here, which I've cut to be approximately a rectangular prism as best I could make it. So it has 6 surfaces. Each of those surfaces is a rectangle. Now this surface looks like it might be a square. That's fine. Remember, a square is still a type of rectangle. So all 6 surfaces are rectangles. So as you might expect, if I cut through parallel to any of the surfaces and therefore perpendicular to some other surfaces, I get a rectangle. So a lot of the things I'll get when I'm cutting through a rectangular prism are just more rectangles as cross sections. However, if I cut off just a corner, so let's do, this corner looks good. So I'm just going to cut through the corner here. Okay, when I cut through that corner, I don't know if you can see that very well, it actually creates a triangle. See the 3 sides of that triangular cross section? Maybe easier to see on here, if I can get it off my knife. Yeah, so when I cut through the corner of that rectangle, I get a triangle.